So if you ever wanted to put in solar power somewhere that you didn't have a building or a shed to put it in to protect it, and you didn't want to go buy one of the larger outdoor rated inverters that usually cost some pretty decent money, well, today we're going to solve that problem. We're going to be building a 12 volt inverter, all-in-one inverter, inside of a rainproof enclosure. That way we can mount it anywhere. And I want to thank Lead Time for sponsoring today's video because they provided us with the inverter, the charge controller, and the battery for this build. So I know the first thing a lot of people are thinking is that this equipment is going to get hot, it's going to overheat inside of this cabinet, but we have installed a cooling fan in here. We also have a thermostat where we can kick the fan on and off based on temperature, and it'll circulate air through here, it'll keep the equipment cool, but also keep everything rainproof at the same time. So overall, I think I'm pretty happy with the way this whole thing turned out, so let me show you how I built it. So as I build this out today, there's going to be several different parts and pieces to this. I'll try to list everything I use in the description down below, plus maybe some of the specialty tools that I use to assemble it. So we're going to be assembling this in a 24 by 24 by 12 inch deep outdoor rated junction box. I think this is NEMA 4X, it might be 3R, but it's a rainproof enclosure. And we want it, I'll try to get as big as I could for under $200. And I want to have enough room for the equipment, plus all of the wiring and everything else that's going to need to go inside of this. So the first thing we're going to start off with is the fan installation. It's got, I think, 3 or 4 main pieces. The first one is a rain hood, and you can see it's got a gasket on the back side to keep it rainproof, and it's going to mount on the side, and then air can flow either up or through this vent to the fans, out the cabinet, keep everything cool. So I've got 2 of these rain hoods because we're going to put a fan on one side and we're going to put an air intake on the opposite side. So the next thing I got is a 120 volt fan. This is a 120 millimeter fan. It's going to go on the inside of the cabinet, blowing out. So we will have openings cut in each side for air to come in and blow out of the cabinet to keep it cold. And over those openings I bought some mesh screens. These are 120 millimeter screens. They are made up to the same size as this fan, but this will keep any insects or critters or anything from getting in the cabinet. And then the last piece of this puzzle is a little thermostat. This is a DIN rail mounted thermostat, so we can mount it in the cabinet, and this will kick the fan on and off based on the temperature. First thing I want to do is drill out the holes to mount the rain hoods, and the instructions have the hole pattern, so I'm going to go ahead and get everything laid out and get all the holes drilled. So the fan's going to go on the inside, but we can go ahead and figure out where we want to put it, mark out our holes. So I've came in about a ½ inch from the edge to be able to mark out my opening I'm going to cut out. So I'm going to go ahead and install the fan with the air blowing out. The screen, it probably could go right on the front of the fan, or it could probably go on the outside. I don't think it really matters as long as it's on there. So you can see that the fan bolt is extra long. It sticks out probably 1.25 inches farther. So I'm just going to go ahead and cut this down, all the bolts down about 1 inch, and then we'll go ahead and assemble it. And to cut the bolts off, I'm just putting them into my wire strippers, threading them in, so I got about, I don't know, 3/4 inch sticking out, and we can cut them off. Just like that. And this side here is just going to get a screen and a rain hood. All right, we've got our enclosure ventilated now so that it can keep all the components on the inside cool, and it's still rainproof after we've made these modifications. So the next thing I want to do is I want to remove this back plate, and I want to start laying out all of the components that are going to go on the inside. It's just held in here with 4 bolts or 4 nuts. So our first component is going to be the Lee-Time 2000 watt inverter. This is a pure sine wave inverter. It outputs around 115 volts AC, claims to have 4,000 watts worth of surge. And I've tested it. It does start my 1 horsepower sprinkler pump, so I know it has a decent amount of surge for an inverter this size. Okay, so if you look at the right-hand side, you're going to see it has 2 AC outlets, 15 amp outlets like you'd have in your house. It also has a display. We'll have to look at that to see what information it has. I don't quite remember. And then it has the on-off button on this side as well. Now this does have, I think it said the self-consumption on this was less than 9 watts. We can test that and find out, but that's very low power consumption if you accidentally end up leaving this on. And it runs off of a 12-volt battery, so it could run off of pretty much any 12-volt battery you could use to run this inverter, like any car-size battery. So I think I'm going to mount this inverter near the top of the enclosure. And then as we wire this up, we'll try to keep all our 12-volt wiring along this side. We'll try to keep all of our AC 120-volt wiring along this side of the enclosure. And we'll keep our voltages somewhat separated in here. So our next component is the Lee-Time 60 amp MPPT charge controller. And this can be used on all different types of systems. So it works on 12 volts, 24 volts, 36 volts, and 48 volts. So it's kind of an all-in-one charge controller. You can hook up for 12 volts. What we're going to be using for is the max of 900 watts that you can hook to it, maximum voltage of 150 volts on your solar panels. So if you want to use this on a 48 volt battery bank, this can accept up to 3,200 watts worth of solar. And if you have a 48 volt battery that has communication, this does have RS485 communication to be able to talk back and forth with the battery. And then it also has a temperature sensor that is included so it can monitor the temperature of the battery bank. So this charge controller, it's a beast. I think it's probably around 4 inches thick. It has like a 2-inch deep heat sink on the back of it. It does have a screen where you can go through and you can set it up for the battery types and the voltages and everything. It's real easy to be able to work through the menu. So for the charge controller, I think I'm just going to put it here at the bottom on the left-hand side. So for the charge controller, it had little mounting feet that you could add to it, and it gets the holes off to the side. It lifts it up just a little bit. So I went ahead and I put those on. So we'll go ahead and build out our terminal blocks. First thing is going to be the end or the stop. And then the next pieces are going to be the ground terminals. And the grounds, they actually grip on to this DIN rail, and they ground it and they bond these two together through the DIN rail. Next thing I'm going to do is put in 4 terminals. And those will probably be our neutral terminals. Go ahead and put a cover on here just to cover up the side of the terminal block. So we'll go ahead and put on 4 more terminal blocks. And this will be for L1 or our positive AC side. Put a covering that up. We'll go ahead and mount our thermostat. So now we want all these terminal blocks to be like bonded together. So you got these little jumper terminals. We're just going to cut off 4 of these. And then you take that and you stick it down inside. And now those 4 are bonded. That's going to be our neutral. Then we'll go ahead and we'll cut off 4 more. And then we'll take these 4 and push down in here. And now those are all bonded together. So now I need to run the AC power from the inverter down to this terminal block. I've got this homemade extension cord. This is 12-3, it's 12 gauge. It's got 3 conductors on the inside. And we're just going to bring it down here, strip it out, and land our hot, neutral, and ground. All right, I've got the terminal block wired up, so I've got hot, neutral, and ground on the terminal block. And then I started putting some of these zip tie mounting points on here. They just screw to the back plane, so I've got one right here. It's holding this wire in place. I've got them going along the bottom, and then I've got them going along the side over here, and that's going to just allow us, as we wire this up, we can zip tie everything down, make sure it's nice and neat. So I've built out the back plane as far as I want to go for now. I want to move back to the enclosure. I've got a battery disconnect that's going to go on the side. We're going to use it to turn it on and off the battery power to the inverter. And then I need to get an outlet mounted to the enclosure as well. And then we've got all of our cable penetrations we need to make. So for the battery disconnect, I got to have an 1.5-inch hole saw. So this here is our battery disconnect. You can see it's got, I don't know, 5/16 lugs here on the back to connect the battery cables. It said this was an outdoor rated 200 amp switch, I believe. But it didn't have any gasket or any way to seal it on the enclosure. So what I did is I did take an O-ring and I put an O-ring around this to help it seal and keep everything waterproof. And then we're just going to end up putting it here in the side of the enclosure. I think that'll work. So for the wiring going out to the batteries and the solar panels, I have some of these. These are like cord grips or cable glands, strain reliefs, whatever you want to call them. So I've got a couple different sizes of these, and I'm going to drill some holes out. I'm going to mount these in the bottom of the cabinet here along the front, and it should work out well for routing our cables. So on the right-hand side of the enclosure, I'm going to mount an outlet. So I've got an outdoor GFCI outlet here, and we're going to mount it to the side. I'm just going to use one of these box adapters. And after I put it through, I'm going to put an O-ring around it, and then I've got some clear silicone caulk. I'm also going to put that around it as well to try to keep this as waterproof as possible. All right, I got my 1/2-inch conduit adapter. Put it through, got an O-ring, put it around it. And then we've got some clear silicone. Take my wires, feed it through. All right. Go ahead and tighten this up. It should help pull it together. Go ahead and put the back plate back in. So the enclosure is all wired up now, and it is ready to power up and test. And I want to take you in here. I want to go through the wiring, show you how I wired it up, how everything is routed. But before I do that, I want to throw out a little disclaimer. This isn't necessarily, it's not meant to be a how-to video. This is just a how I'm going to do this video. Not everything in here is probably the exact way it should be done. It's just the way that I'm doing it. So out of the bottom of the enclosure, we have 2 solar panel cables with MC4 connectors on it, ready to connect to some solar panels. Those route up right into the solar panel input on the charge controller. And on the left-hand side, we have the negative and the positive battery cable, and I've got about 4.5 feet of it running out the bottom to be able to reach a battery. So my positive battery cable comes up, hits one side of our disconnect, and then it is doubled up with the positive off of the charge controller. So that means when this switch is off, the charge controller can still charge the battery. So the charge controller is on all the time. And then the disconnect, when you turn it on, it provides power up to the inverter and it comes on. So really this disconnect switch is just an on-off for the inverter. So the negative battery cable goes straight up to the inverter, and then it is doubled up with the negative from the charge controller. So from our terminal blocks, we have power coming out to the outlet on the side of the cabinet, and then we have power going through our thermostat and then up to the fan and then back down to the neutral. And you can see we still have open terminal blocks here, so we can wire more power out of the enclosure to other things if we want to. So the battery we're going to use to power this up is the Li-Time 12 volt battery, and this is a lithium iron phosphate battery, has 100 amp hours of storage, and it can output 100 amps out of the battery. And this is a self-heated battery as well, and it's their new version. So it has, I think, a slightly bigger heater on the inside for cold weather. So this will work perfect with this, you know, in an outdoor environment. We'll go ahead and get this battery hooked up here. So our disconnect is off, so the only thing powered up is the charge controller. You see it's 13.1 volts right now. It says it's 95% capacity on the battery. I'm gonna go ahead and turn on the disconnect. The inverter came on with that little beep. So the way I have it mounted, you can't see the screen on the side. So it displays two things that I can see. One is like a battery's percentage, and it's kind of like your cell phone, right? It's like 4 bars. And then there's also a digital display on the wattage output, and it's showing that it's like 0 watts right now. Of course, we're not using it. So right now I've got the thermostat set at 35 degrees Celsius. If I turn this down, it clicked there. The fan came on. Hopefully you can hear that. Blowing air out. So I went ahead, I turned that back up to 30 degrees Celsius. That's around 86 degrees Fahrenheit. So I plugged in a heat gun. I believe this is supposed to be 1600 watts. So we'll turn it up. So I can see the display, I can read it from the way it's mounted. It says this is about 1220 watts, so not quite the 1600 that they advertise. So this here is a 7-inch angle grinder. It's one of my bigger hand tools. It says it's supposed to draw 13 amps. Now you couldn't hear it, but the inverter actually beeped when I started this up because it hit the max inrush. I experienced the same thing when it started the pond sprinkler pump. It will beep, but it still starts the device, but it knows it's maxing out its amps. I found something bigger. This is my Evolution metal cutting saw. This is supposed to draw 15 amps. All right, here goes. So it looks like our wiring's good, our inverter's good. The only thing left to test is the charge controller. Get some solar panels hooked up to that. So let's go ahead, we're gonna get this outside, get it mounted. So for the 12 volt battery, I bought a battery box, and this is a group 24 to 31. You need this bigger group size battery box for this to fit in. And this is just gonna help kind of protect it from the weather and the sun, and it'll also cover up our wiring connections so that they're not exposed. Makes it a lot easier with those keyhole slots to mount it. Just reaches. All right, shows that we got solar going into the batteries. It's putting in 12.4 amps of solar right now. Then it says the solar panels are 63.5 volts. 12.6 amps times 63.3 volts, 797.5 watts. So I've got 800 watts of solar panels hooked up to the charge controller. It's charging the battery. Everything seems to be working fine. So we'll go ahead now and we'll go ahead and hook it up to the sprinkler pump and we'll test this out. So with this outlet mounted on the side, it just makes this plug and play. You can just take it and use it anywhere, but you can still hardwire stuff to the inside if you want. So I think this is going to work out good. So go ahead and turn on the inverter. You could hear it beep. And when we kick on this sprinkler pump, it's going to spray like 20 feet outside this garden. This thing's going to get completely soaked with water. Luckily it's rainproof. We're going to let the sprinkler probably run for an hour, and then we'll come back and we'll check this. We'll see if we got any water on the inside. All right, here we go. It's a little slow starting it up, but it started it. Yeah, it's coming all the way out. Almost hit the camera with the water. Yeah, you can see the water and how far it shoots over the garden. Shoots pretty far. Try to get a quick look in here in between showers. All right, just curious. Looks like 990 watts, about 1,000 watts to run that pump. All right, I gotta close it up quick. So I ran the inverter until it shut down on low battery voltage. So we drained the battery. I let it charge back up on solar for a little while, and then I ran it a little bit longer, and now it is charging up again with the charge controller. So when this airs out on low battery voltage, you do have to turn it on and off to get it to restart, to clear that error. Now the charge controller had a low battery voltage, and it cleared itself once it got the battery charged. But I think this build is a success. We have a rainproof enclosure that we can pretty much mount anywhere and be able to have 120 volt power wherever we want to put it. Easy to hook up solar panels to. So a couple things I could have probably done differently. I could have probably just plugged the fan directly into the inverter, and anytime the inverter was on, the fan could have ran instead of using a thermostat. The other thing I could have done, I could have used a 12 volt fan, and I could have ran it off basically straight off of the charge controller, and it would have ran when the inverter was off. Right now the fan only runs when the inverter's on. And the other thing that probably needs to be done is it probably needs an external ground rod or a wire coming out that I can run to a ground rod so that I can ground this cabinet. Right now it's physically not attached to earth ground. So I want to give a big shout out to Lead Time for sponsoring today's video. They did provide the inverter, the charge controller, and the battery for this build. And right now, as of I think October 8th and 9th, they're doing a sale. They have, I think it's a Prime Day special, but they've got a sale going on, and then I've got a discount code as well. So if you use CVS DIY, it'll get you an extra 6% off if you want to buy any of the Lead Time products. I'll go ahead, I'll put links to all this stuff down in the description below, along with all of the parts that I used to build this project. So I don't think this is going to be the permanent location for this project. We built basically an all-in-one 12 volt inverter that's outdoor rated, rainproof, and I can put this anywhere. It works good, I think, for this application right now, since we are kind of in a drought condition. But I think in the future, when I rebuild my firewood shed, I may want to put up some lights, have some outlets, and this could be a good power source for that location. I could throw a few panels on the roof, and this could be the power source for really any outbuilding or any spot on my property if I wanted it to be. But pretty cool little project. I think it'll come in handy. Only like a couple, 2-4 bolts, take it out, I can move it somewhere else and put it at another spot. So I think it'll definitely get used throughout the years. So pretty neat little project, but I think that's going to be it for today's video. So thanks for watching, and I'll see you in the next one.